Good morning, class. Today we are going to continue with circle theory. And the first thing I want to look at is what a circle is. Okay, a circle is a two-dimensional shape that is drawn such that every part of it is equidistant from the center. And a circle can be divided radially. It is radially symmetrical, meaning it can be divided into two parts from any plane. Okay? In a circle, a line that is drawn from one end to the other end is called a diameter. And a line that is drawn from the center of the circle to any point, to any end of the circle, is called the radius. A chord is a line that is drawn across the circle at any point other than the center. And the circumference is the distance around the circle. Now, we'll continue with theorem 14, which is the first theorem we're looking at in our circle theorems. It says that a straight line drawn from the center of a circle to a chord bisects the chord and is at what? Right angle to the chord. So if I draw a circle and a chord is here, like this circle is here with the center O, the chord is drawn as a line AB. Okay? When a line that is drawn from the center of the circle to this chord is not the radius, because the radius has to get to the end, the point of the circle. So this line that is drawn here bisects the chord into two equal parts. That is what the word bisect means. Bisect means to divide into two equal parts. So we divide the circle into two equal parts, and it's at right angle. It's at right angle. So that's the first theorem we look at. It's a simple theorem. So if this is at right angle, it means that what we are having here is what? A right angle triangle. And this other part is what? A right angle triangle. That's something to note. Then the next theorem we'll look at quickly is theorem 15. Theorem 15 says that equal chords of a circle are what? Equidistant from the center. That is, they have equal distance from the center. So these two chords are similar and they are the opposite point of the circle. So the theorem is saying that from this point XO, that's from the point X of this chord to the center of the circle, is equal to the point what? Y to the center of the circle. That's theorem 15. So let's take a look at a few examples on this. The first example says here, it says that a chord of a circle is what? 16 centimeters. So let's follow the instruction that is given. So if I have a circle, we are saying that the chord of the circle is what? 16 centimeters. So this is AB. It means the length from what? A to B is equal to what? 16 centimeters. Alright? 16 centimeters. It's calculate the radius of the circle if the chord is what? 6 centimeters from the center. So if this is the center, now we should note that the diagrams we are drawing here, they are not to scale. So if this is the center of the circle, we are saying that the center of the circle is what? 6 centimeters from the what? Chord. What are we asked to find? Calculate the what? Radius. So the radius, we said, is a line that is drawn from the center to any point. So we can pick this point here. Now if we make reference back to theorem 14, theorem 14 says that what? A straight line drawn from the center of a circle to a chord bisects the chord and is at right angle. So here, it means this is what? A right angle. And a right angle is an angle that is what? That has one side of it at 90 degrees. So if this is a right angle and this straight line bisects the chord, then we can therefore say that the length, let us call this point what? X. It means A to what? AX, the line AX is equal to what? 8 centimeters. Because half of 16 is what? 8. So this must be what? 8 centimeters. So if this is 8 centimeters from our Pythagoras theorem, okay, this is the center of the circle O. We can say that the square of the what? Opposite side, let this be our angle, reference angle. The square of the opposite, which is what? OX square, is equal to what? Sorry, the square of the hypotenuse, AO square, is equal to what? The square of the opposite angle, XO square, plus what? The square of the adjacent. The adjacent is the base angle. That's what? AX square. So AO is unknown, which is our what? Radius. So if AO is equal to radius, you can say that what? R squared is equal to what? 6 squared plus 8 squared. So from here we can say R squared. What's the square of 6? 36. And the square of 8 is what? 64. So R squared, so someone should calculate for us. 36 plus 64, what would that give us? 100. So therefore the radius is what? The root of what? 100, which is equal to what? 10 centimeters as the answer, with the help of theorem 14. Okay? The next thing we'll look at, I hope we have written this part, so I can wipe this part of the board off. Let's look at example 2 very quickly. Let's look at example 2 very quickly. Do we understand this calculation here? So let's take example 2. Solution to example 2. Example 2 says, calculate what? The length of a chord. Now they're asking us to find the length of a chord. Calculate the length of a chord of a circle, and the radius of the circle is what? 13 centimeter. And they're giving us a few conditions. They say if the chord is what? 12 centimeter from the center. If the chord is what? 12 centimeters from the center. So we have our circle here. You can draw the circle this way, and we choose a point. So the chord is what? 12 centimeters from the center. We have to find the length of the chord. So if this is the chord, this distance is what? 12 centimeters. This is O. I call this AB and call this X as usual. And this is the radius. The radius, what's the radius given to us there? 13 centimeters. So we can, this is the point AX. So we can say from theorem 14, recall that theorem 14 says that what? A line that is drawn from the center of the circle to a chord bisects the chord and is at what? Right angle. So if we bear this theorem in mind, we can therefore say once again that what? AO square is equal to what? XO square plus AX square. So from here we can say the square of 13 is equal to what? The square of 12 plus what? AX what? Square. So what's the square of 13? 100 and what? 69. Now the square of 12 is what? 144 plus AX square. By collection of like terms, when this 144 crosses the equal to, it changes to what? Minus. Because when a positive sign crosses the equal to, it becomes what? A negative sign. And when a negative sign crosses the equal to, it becomes what? A positive sign. So we have 169 minus 144 is equal to what? AX squared. What's the difference between 169 and 144? That's what? 25. So 25 is equal to what? AX squared. So we also remember, if you remember from previous class we had, we said that when a square crosses the equal to, it changes to what? A square root. And when a square root crosses the equal to, it changes to what? A square. So from that we can say that AX is equal to what? Square root of what? 25, which is 5 centimeters. 5 centimeters. But recall, you know, we can remember that this line OX bisects what? AB. So we can therefore say that what? We can recall that what? AB is equal to what? 2 times what? AX. So which is what? 2 times 5 centimeter. And that will give us what? 10 centimeter. So the whole length of the chord is what? 10 centimeters from our calculation. Alright? So let's go to the next theorem. Let's go to the next theorem. So let's quickly take down this note here.